Yeah, hello and welcome to our lecture series on climate protection. First, some organizational point of view. So some of you asked me about the task. To clarify, you have to do the task as written in the PDF at OLAT, plus the task described in the last email. So please upload both tasks on OLAT on your participant folder. Yeah, and today we have a special guest, Christian Matt. Christian will present an innovation project in a cement plant today. He's working for E.ON Business Solutions as a solutions and application manager on different energy efficiency projects in industry. Before that, he worked for TÜV Süd in Munich, and he was project manager at Transolar in Stuttgart. Actually, we learned to know each other at 20 years ago when he was a student at the University of Stuttgart, when he worked on the thermal solar chimney for natural ventilation. That was his work there. Yeah, and today we are looking forward to his presentation on the use of waste heat in the cement production process. Welcome, Christian Matt. Thank you very much.
Hello, welcome from Christian here from Stuttgart. A very warm welcome. We have, I think, the same temperatures as the new in Austria, in Innsbruck. And I will introduce you a little bit in a cement production process, which is not more warmer than you in if you have ever been on this site, because they had a lot of heat inside the plant, and so it's very hot if you're standing under a rotary kiln. I will show you a little bit from the plant. I make an agenda for this day. One moment. So the agenda is, I've drafted a short agenda. So the first point is about my person, but Mr. Pfluger or Rainer said something about it. The next point one to the second is I will introduce a little bit in the cement plant, the production and the heat flows in the production. It's very important for you to understand what we are doing there and why we use where and why we use the waste heat recovery. And the third point is that I will show you the conception for the waste heat recovery. And the last is I give you time for questions to me, and perhaps I can answer these questions. So I will start with not about me, so about E.ON Business Solution. You see it. We are a unit in the E.ON world. E.ON world is a very big world. It grows up the last 2 years with energy persons. So we are at the moment, I think, so 100,000 persons in the E.ON world. But we are a special unit there. E.ON offered electricity and heat and gas, but we offer to our clients solutions, energy efficient solutions. We do not we are not interested to sell electricity or gas. We are interested to sell solutions, and with solutions as our clients can save electricity and gas. Especially in here is we develop a project together with a client, then we make the planning for this project. If the client wants, then we finance this project, and at the end build the project and operate the project in the industry. That is what the industry needs, because normally the industry have not so much power and not so time to make energy efficiency project, but they have to do it to reduce the CO2 emissions. At the moment, we are approximately 55 employees here in this unit, but we are combined, or we are working close together other units if we need it. So we have, if we need, we can grow up this our group. Our annual turnover is approximately 100 million euros. That was the last years, but we have very hard subjects for the futures. Then I will go to the next point, the cement production. Therefore, I have a picture for you. That's at the first moment. This picture shows the cement production process. At first glance, it seems very complex for you. I think so, but with my explanation, I think you will understand it well. At the top, you see see limestone and clay quarry. That is the mining, and that on these two basic materials from this the cement will produce. And but first the basic materials has to crushed. Here with stone crushers, you see here is all crusher, and it has to dry, and then it goes after here. It has to store it in a big silos, and in the end it goes on this silo, and from this silos it will come into the production. So in the middle, with the number 1, you can see the rotary kiln. That's the central element in the production, in the cement production, because that's the materials have to go through this rotary kiln. That is a big kiln with a diameter of 5 meters, which is rotary. I don't know exactly the English word for it. You see in here, says the burner is coming from the left, and the material is growing from here. You see the pointer from here to the heat exchanger tower, here inside the rotary kiln. The rotary color is as a heat exchanger tower is called heat exchanger tower because the exhaust from the kiln is going this way. The material is going from the up to down, and the exhaust is going from down to up here. So the material is heating up here in every step, and goes then with a temperature from 800 Celsius through the rotary kiln. And here on the end of the rotary kiln is the clinker cooler. And here the material is called clinker at the end of the kiln, and the clinker has to crush crush before it becomes cement. So the clinker is going this way to a clinker silo and going to the cement mill, where the after cement is going through the cement sill, and here's the cement silos for the truck, where the trucks are going under this and transported the cement at the end, or the cement is has to go to the mixer, where is mixed with other materials. This site is a special site here. It's only on this side in Dottenhausen in Holcim. They have oil mining here area as well, mining here, where they use the slate and use the slate for to produce electricity, and they dry this slate and mixed it at the end here as well, here to the cement. But we will come back here to the kiln. You see here the fuel for the main burner. The main burner is on this side here, and what they are as the fuels are coal, heavy oil, sewage, sludge, biomass, and bone flour. Also all materials, heavy materials, which are very billig, not expensive. And there is another fuel materials for the calcinator, that they are all tired from cars, tar paper, paper fiber, fluff plastic from the yellow sack. We have the yellow sack here in Germany. I don't know what you have in Austria. That's all. That's the burner here for the calcinator. So we have, and that is the main part of the cement industry, and we have heat on this side and we have heat on this side. Here, the heat on this side normally is going to the evaporator cooler. This is number 3, and the heat on this side, this is the exhaust side, and this is the air side here. Here we have the clinker air cooler. Through the clinker cooler is the push air or blow air, and this air is very hot, and there's an air cooler, and so the heat from here is going to the atmosphere. And in the next picture, I will show you it's an easier picture. First I will show you some pictures from here. You see the numbers here. That you get a lot of impressions from a cement plant. I have some pictures here. You see the numbers here, and so you can see on the next pictures what is here. What is this here in this schematical picture in the real dimensions. Here, for example, here the number 1 is here. The rotary kiln is here with a diameter from diameter from 5 meters. It's very hot if you go through here, and it does rotary, and the material is going from here through this is here is the heat exchanger tower. Next picture is here. You see here the heat exchanger tower here. It's the biggest. If you have ever seen an cement industry in the future, you know the biggest thing in the biggest tower here is the heat exchanger tower, and the material have to You have to bring up the material up to here, and here the material is going this way down through different material heat exchangers and going here to the rhetoric kiln. And the exhaust is going the other way from here to here, and is going up to here. And this is the evaporator cooler. It's a cooler where is a cooler where is water is blown. The exhaust is going through the cooler, and a lot of water is blown inside. And in this process, the exhaust will cool down. This is important to go later through the filter. This is another picture from the other side. In the next picture, you see the number 4. This is the side from the air side. You can go back a little bit. So you see here. We are now here on the air side. So there is a clinker air cooler and the filter number 4 and number 5. You see here. So number 4 is this here. Here's the air on the right side. The air is going this way through this box and going through here up to here, and at the end it's going on this side, and this side is a filter, and the air has to cool down because the filter, the air is here, it has 350 grad Celsius. They have to cool down. The heat is going in the atmosphere here, and then the air is going this way to the filter here. So, and the next picture, it's much more easier for you. It's the same picture like the picture before, but it's very easier explained. Here you see the exhaust air, and here the air side, and here you see the exhaust. Here is the return kiln. Again, so the exhaust is going this way in 4 steps. There's a heat exchanger power. Then is here the evaporator cooler. That is there is I don't know. The exhaust can go this way, or if the raw mill is in work, so it goes this way. Then it goes through the exhaust filter and at the end on to the chimney. And the other side is here the exhaust air, the clinker cooler, the clinker air cooler we have seen at the picture 4, and the filter and the chimney. And our concept is now to use the energy you cool down here on this here, and you cool down here on this here. And I show you here the concept here. So you see here, now we make a bypass before the evaporator cooler, and we will build up a heat exchanger through between the exhaust, and will build up a thermal oil system or a water system, and brings this water system in a second heat exchanger where we can use this heat for heat about 11,000 kilowatt heat, and we have the chance to bring this heat in a district heating, or we can use this heat with an ORC unit or with several ORC units, and we can use and we can produce electricity power so around 1,300 kilowatt electricity with this heat. That's the chance to do it on this side. And the special on this here, because it's not done in the past in the cement plant, is that there is a lot of dust here inside the exhaust. Normally they have a lot of dust exchanger here, and bring the dust then back to the production, or to the material which is going to the rotary kiln. But the dust will make us a lot of problem in a normal heat exchanger, and so we make a lot of studies to create a heat exchanger for the dust with an automatical cleaning system to clean this heat exchanger, that otherwise we will get foulings here, and we cannot exchange the heat here. In this case, if this will not then we have to clean it by hand. But I hope so. It will not. That will not. Yeah, I have not. It will. I hope so. It will work. Otherwise, we have anyway. We have the here. After this heat exchange, we have anyways the evaporator cooler, and in this case we can use evaporator cooler. This is the side of the exhaust side, and we have the same system on the other side, where we have a heat exchanger for the clinker cooler before the normal clinker cooler. And we have here as well in ORC units, so we can, if we use a heat exchanger, we can produce around 9,600 kilowatt, and feed it in a district heating system, which will both heating networks, district heatings, have to build up. They will then the heat will they have to build up the district heating. It will have a length of 9 kilometers. And it will need, I think so, next 5 years or 6 years to build this up. In this time, we can use the ORC units, and we can use the ORC units in summer times when the district heat do not need so much heat. The next picture, you can see a little bit the dimensions we have to do here. This is the heat exchanger tower you see here, and we have this. The red one is here. We have to go out here. We go to go out here from the duct here, and that is a heat exchanger here. We have to build up it. It's very heavy with 200 tons and of a height of around 20 or 25 meters, because under the trucks have to go through here, and we have to the duct after the heat exchanger have to go this way up to the heat exchanger tower. That's the technical setup for the evaporator cooler. The ORC will will build up on the floor nearby the heat exchanger, the new heat exchanger. That's the technical setup for the clinker cooler. We have seen here you see here's the filter, and here behind this is the new heat exchanger here we have to build up behind. We have seen the old heat exchanger, and we have to go from here. We have as well to build up that's the red one to go on the duct here and build up the red new duct to the heat exchanger, and out of the heat exchanger the blue duct is going back to the old duct and go up in this mixer here. So that's the task we have on this side. So that was all I wanted to show you. And now you have to have chance to send me some questions.
Yeah, thank you, Christian. Thank you very much for that impressive presentation. That's really, really huge. I think to grasp the dimension, it would be nice to have an excursion tour to see such a site. It's so impressively huge. And I've been in the cement industry once, and as you described, the heat is tremendous. Yeah, this rotating tube is so hot, and you feel like grilled below if you are close to this hot duct.
Yeah, if you ever been in Germany, or you have the chance, or as in some cement plants in Austria as well, you have they have all. Sometimes they have visitor centers. In Dottenhausen, they have a visitor center, and it's very impressive to go in this site here to show the cement process.
So it's only in Germany, in Dottenhausen. You told in Austria it's also visible?
Yes, in Austria as well. We at the moment we do 3 project in the cement industry, but Holcim has as well. No, Heidelberg Cement, they have as well plants in Austria.
Okay, maybe you could write me the location, then I could
Yes,
show it to the students. Maybe that.
Yes, yes. It's not so far from you. I can give you in contact. It's in the Inn Valley.
Right. We have a question in the chat. It says, will this be the only source of district heating? Does it run 24/7? Is the main motivation reducing costs or CO2 reduction? Could you answer these questions?
The district heat, there is on this side there is a small district heating, but only for a very small village. In the future, we will bring the heat to Balingen. It's a bigger village, and they have to build up this district heating. And at the moment, we have no idea how many heats they need. That we are in the discussion how many heats they need in the future, and which temperature. District heating normally in Germany in the past are in the temperature from 80 to 90 Celsius. So that's the first question. The second was what was, I don't know. Rainer, can you repeat?
The second question is, was the main motivation reducing the costs or the CO2 reduction? I think both are. What
Yes, the main was to reduce the CO2 reduction. The cement industry is one of the biggest company plants or I don't
domain.
know
Yeah.
domain who have the heaviest CO2 emissions in the industry.
So around 8% of the worldwide
yes,
emissions
yes,
CO2 is due to cement industry.
Yes, that's because in the future we have to reduce the cement or beton, but it's too concrete. Yes, it's too, because it's so cheap. But I think so. If the CO2 emissions will be increased, or I say CO2 price will increase in the future, I hope so. The cement or the concrete will increase. They have to increase the price for concrete, so it will not be so easy. So and it will not so cheap. Will not be so cheap to build up the houses or the buildings only out of concrete.
Yeah, there's already a shift from concrete to timber construction.
Yes, I hope so.
Yeah. And just for the students to imagine the heat recovery, what you showed us here, it's if you heat and have domestic hot water for passive houses, it would be around 12,000 buildings you could supply with this district heat. So that's really huge. And this was blown in the atmosphere before without any use. So that's a really good heat recovery. Yes,
yeah. How do you calculate that is? I think it is 20,000 houses. I would calculate 1 kilowatt for one.
Yes, I only calculated the district heating, but additionally you have
okay, yes,
power,
okay, yeah,
electric power.
yes.
You have additionally. That's additional.
Yes,
For sure.
yes, that's really.
Great.
But normally you can in a passive house you can use heat from 330 Celsius. This heat we do not use here. We only use the heat till 90 Celsius, because we have otherwise we will have problems in the with was heißt in the chimney.
Yeah.
With condensation. We have so we have problems with the condensation. So only and in the one chimney we only the heat has to have 90 Celsius and the other 120 grad Celsius. So there are, if there are other questions.
I would have some question on the insulation of this duct. So it's steel outside, and there's no. I've not seen on the photo any insulation. Is it uninsulated?
Oh yes. You have to insulate the duct, the new duct or the old duct. They have, of course, they have insulation on the old duct because the steel, the temperature are very high, and otherwise they have to refurbish the steel every several years. They have to refurbish as well the stones inside the rotary kiln every year. Not all, but some of them. They are in the burner areas, near the burner. The stones inside are very high temperature inside, so normal cement plant is down 6 weeks every years in winter time, more normally in March, because then it's very low temperatures in the around, so it will cool down very fast. But they need to refurbish the stones inside on some places, and they have insulation. They have to have it.
Okay. Any other questions from your side? What about your opinion in for the future? What will we do in post-carbon times? So just imagine if we don't have any coal or gas, nothing carbon-driven heat, how to produce cement in future? Will it possible? Or how could be the technology
Yes,
then?
yes. I think so. They will produce cement in the future, but with hydrogen. They will use hydrogen in the future. There is no other way. As it's the same as like in the steel industry or glass industry. We have other project in the steel industry and in the glass industry. In the glass, normally they use gas, and in the future they will use hydrogen or biogas. But we have not so much biogas in Germany, and the biogas they will use normally in smaller buildings or not in the industry. And so that's because they have to use hydrogen. That's because I think the usage of hydrogen in the future will be only in the industry, not for the normal people, or not for cars, because we will have a lot of problems to produce so much hydrogen, and we have to have our industry, and we have to produce steel and cement, not so much perhaps, but or not so cheap, but we have to produce it because there is no opportunities, other opportunities. But I think so. Concrete or cement will increase the price for cement.
Well, in the steel industry, hydrogen is necessary for chemical reasons also.
Yes.
Is the cement industry is the same, or could we use electricity directly?
Yes.
Heat
You
by
can.
electricity.
Yes. Yeah. Normally you can. Yeah. But then you need another kind of heater and induction Induktionsheater. That's not normal in this kind of industry, but it would be an opportunity, but I don't know. But then you have as well the heat, because you need the heat for them, and we can use the heat as well with our system.
Okay. And then my last question would be about the cleaning process. I think that was the key issue why it was not done up to now. So heat exchangers are a really old technology, and this is a waste of energy since the last decades. The heat was not used up to now. Now you did it, and I think the highest innovation part is this cleaning process. And so it's automatically, or can you do it continuously? You run the system and you do the cleaning, or do you have to interrupt it?
Yes, it will do. At the moment, we have one plant in near Austria, in Rohrdorf, near Rosenheim. They have this. They have a heat exchanger with an automatically, and we cleaning system, but it will not work as well and we have to verbessern,
Enhance, to enhance.
enhance the system, and we will do it with an electrical pulse. They there in Rotterdam they do it with hammer, das heißt
Hammering impulse.
hammering systems, but it's not so good for the material and the heat exchanger, and they hammer all parts of the heat exchanger, and normally it will be at the first of at the beginning of the heat exchanger there will be a lot of dust, and at the end there is not so much dust. So if you hammer all, you will in the future the material will break very easier. So we will use an electrical system, a pulsing system to clean it up.
Okay. Yeah, that's really
But it's like a hammer, but it's not the power comes from an electrical pulsar.
Okay. Yeah, that's a really interesting technique, because these fouling problems for heat exchanger really a common problem in industry.
Yeah,
Maybe
yeah.
it's not only for the cement industry, it's for many dirty industry plants to use that, and it could help a lot.
Yes. But you have to look of the material which is going through the heat exchanger and the fouling system, and then you have to look for a cool cleaning idea, because there is another kind of heat exchanger. They have a ball, and it's called a Kugelregelanlage. It's a ball rain system. So balls there's a big tower, and the heat exchanger is in the tower, and they let balls running from the top down through the heat exchanger, and on the bottom they say then there's dust and the balls, and they transport the ball again to the top.
That's so circulating around for cleaning the walls.
Yes.
Okay. Yeah, that's similar in the swimming pools.
Yes.
There are circulating sponge balls, but in this time it's metal, I think.
Yes.
Balls, yeah. Yes. Great. Okay. Yeah, really interesting. So, any further questions in the audience, in the chat? There is no. So, yeah. So
then
I would say thank you very, very much, Christian, and for the students for coming and for the questions. You'll find the slides on OLAT if you want to read it more in detail. Yeah, and then we'll see next week, I think, for the last lecture. Thank you very much. Thank you, Christian.
Okay. Thank you to you, and a very nice evening to you.
Thank you.
You're welcome.
Thank you.
Bye.